Alright, well, that cut off, so I will try to, I'll write it now. Alright, so I suggest it's always a good idea to start with the negative rule, which says flip all of those. So I'm going to rewrite it. Actually, I'm not going to rewrite it. I'm going to flip them, but first I see this quotient rule, which would be easy to do. So I'm going to do that part first. That part first. So 2 and 3 have to stay because they don't divide nicely. 4x is on top, x to the 4th, and then 2x is on the bottom. So when you cross out, you're going to have 2 x's left over up top. So I'm going to write x squared. Then these y's come down, these y's come up, these z's come down and get combined with that. So I'm going to do the y's next, y to the 4th, then y cubed gets put up top to make it positive, z to the 3 comes down to make it positive, and we already have a z to the 4. 2 and 3 still don't divide, so they gotta be listed there. Then we have this x squared, and there are no other x bases, so there's nothing else to do, so it has to stay. Then we have these y's. This is a quotient rule because it's y cubed divided by y to the 4th. Quotient rule, subtract the exponents because cross out, cross out, cross out. 1 y left over on the bottom. So put that down there. And then we have this, which is a product rule on the bottom of the fraction, on the denominator. So we have 3 z's, and then we have 4 more z's. This is not negative, it's supposed to z. So totally we have 7 z's. All different bases, so we're done. Alright, moving on to number 27. Ooh, my favorite! Zero rule gets crossed out. The 0 does not apply to the 4 because there's no parentheses wrapping that 4 in with the x. And then we've got a negative rule, and so that's going to have to flip down. And then look here, 4 divided by 4. Any number divided by itself is 1. So this is actually looking pretty darn easy. We've got a z cubed on top, we've got an x on the bottom, and we've got a y squared on the bottom because this one moved down. Now, we can't do anything else because they're all different bases. Boom, 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 boom. So that's the answer. Next one, 28. Okay, what do you think? We got a quotient rule because it's a fraction bar. We got a 2 and a 3, which don't divide nicely. We have a negative rule, so I'm going to move those down. And then we have a quotient rule. Remember that every exponent has a secret exponent. Every base has a secret exponent of 1 if there's nothing listed already. So 2 and h cubed, and k to the 4th divided by k1 is k cubed over 3j, and then we took out that k. Oh, can't forget to move this j down to make the exponent positive. Almost done. What do you see here? I hope that you just said a product rule, because that's a product rule. And we're almost done. So this chunk right here, see how they both have the same exponent? You don't have to rewrite it like this, but you can, and just to show you, I will. So 2 and hk cubed divided by 3, and then the product rule right here. secret exponent of 1, and then another 3 j's, j to the 4th. And then we're done. And remember, these are all secretly being multiplied, even though you can't see it. All right, on to the next part. Okay, 2 more problems.
No.
We have a quotient. We have no negatives. Here's a quotient with the m's. Here's a quotient with the n's. Here's a quotient with the p's. So 4 and 3 don't divide nicely, so you just write them, transfer them. We have 4 m's on the top, 2 m's on the bottom. Cross out, 2 m's left on the top. We have 3 n's on the top, 2 n's on the bottom. Cross out. 1 left on the top. Don't need that one, but you can have it if you like. 3 p's, 4 p's, cross, 1 p left on the bottom. Answer. Alright, last one. I see a 0 rule, my favorite. I see a 0 rule. I see a negative rule, a negative rule, a negative rule. So, rewriting 3x cubed, and I'm going to move these x's up top, x to the 4th, and then these two both move down, and they have an exponent of 1, so I'm not going to write it. I'm just going to write y, z. Last thing is the product rule right here. So 3x, y, z. However, how many x's? We have 3 being multiplied together here and another 4 being multiplied together here. So we have 7 total x's, and that's it. We have not, I'm not going to get into these fractions because we haven't addressed that yet. That will be for another video. Thanks for watching. Do your homework. You made it. Bye.